Welcome back to the course. I hope you enjoyed my previous session. It's about learning artificial intelligence through human intelligence. As I mentioned, there are 6 major fields: machine learning, deep learning, computer vision, data science, natural language processing, and generative AI. So in this video, we are going to see in detail about deep learning field. As I said, deep learning is all about deep. For example, there is a difference between the normal person and the medical doctor. The normal person will do some kind of mathematical operation and lot of basics data and basic kind of calculations, but the medical doctor can able to understand deep level knowledge. For example, like he can understand CT scans, MRI scans, lot of surgical things, like he has some deep knowledge in specific field, right? In same way, the deep learning will learn the data in very deep. For example, identification of disease in CT scan, MRI scan, and classification of multiple different kind of fruits or different kind of objects, like that. Wherever deep level understanding is needed, there deep learning came into the place. So now we are going to understand how deep learning started, how it's evolved, and what are the challenge it faced while evolving, and what is the current stage of deep learning, how it's shaping the future step by step. Before we dive into deep learning roadmap, we have to understand what are the key terms like which I will be using in entire video. For example, I'll be using word like weights and biases. For example, I said artificial intelligence is a 3 major part. One is the input as a data, and then middle as the processor, and third will be the output actions, kind of classification with respect to the deep learning. For example, input we are clear and output we are clear, and the middle part there are a lot of evaluation and challenges are faced during the roadmap, and I'll be using lot of key terms over there. For example, like there is weights and biases. For example, if you take radio, we will be adjusting knob for adjusting the frequency, right, to get the exact kind of like a song or anything what we want to get. The adjusting of that frequency based kind of adding some noise or kind of adjusting that knob, that similarly we can consider as a weights in the deep learning. And then bias is all about the controlling the volume. Like the bias, it changes the entire tone of the, it can be any noise or any audio which comes out of frequencies. It can be completely upgraded or downgraded with the help of the volume knob, right? That is the bias in terms of deep learning in simple way of understanding. And then we call it as function. For example, step function and then softmax function. For example, if you want to do binary classification, whether the image is dog or cat, whether the image is bottle or kind of a bigger thing, any one binary classification, differencing between 2 part, like with this a mobile phone is a kind of like Android phone or iPhone, kind of the 2 classes problems, their step function will come into the play. Whereas we need multi-class problem, whether it's a dog, a cat, or a horse or cow, the multi-class problem also we need probability. What is the probability at which it predicted? For example, 99% I'm sure that this is a cat, I'm the only 50% sure that this is the cow. Like that, probability based multi-class problem will come under the softmax function. So these are the basic keywords. And then the deep learning mostly deal with the image. It also works with the text, but in the most scenarios it works with a lot of images. As we know that we have to understand what is the image. Image is the building block of, it's a group of pixels, like a group of pixels come together, it forms an image. When we look into the pixels, it can be 2 category. One is the black and white grayscale pixel, the another one is the color pixel. When it comes to color pixel, there are 3 major value. We know that RGB, which is the color red, green and blue. Based on this value intensity changes only, each color will be getting from the image. So this is the RGB values which is common in the color images. Next on the grayscale image, it starts from 0 to 255. The white color balance to up to black color, from it start from 0 and then goes up to 255, so that we can vary the different intensity of color between the white and black. So it's completely grayscale. So when it comes to image, it can be either grayscale or it can be color image. So and we understood what is a pixel and what are the 2 different grayscale and like color pixels are there. So now we can good to start with the roadmap. So initially deep learning started around 1950s, and we all know that today the people are speaking about AI, and we are thinking of like last 2 to 3 years only this kind of innovation happened in the AI, but the basement like happened 50 to 60 years before. In 1958 itself, a person named Frank Rosenblatt, he invented a simple artificial neuron called perceptron. This is the game changer of AI, which is the complete basement initiation of AI, which makes possible of replicating the human intelligence. Now we see how perceptron works and what is the advantage of it and what is the disadvantage, or we can call it challenges that perceptron faced. As I said, like a perceptron is a simple artificial neuron that has simple kind of binary classification task. For example, it has image as the input. It will detect the features, only pixel feature it takes from the image, and then middle part and then output part. So middle part, it has some weights and bias. It will take the pixel feature from the input, and then it will add some kind of noise kind of data kind weights and bias into the data, and then it will reshape the data, will get the features from it, and then finally it will apply the step function, binary classification function, and then it will provide the output, so that we can able to calculate the given image is like whether it's a dog or cat. The step function acts as based on the threshold. The simple meaning, threshold means that, for example, there are features we will get from the input after applying the weights and biases. The output value, for example, it is more than 50, then we can consider it as a dog. If the less than 50, then we can consider it as a cat, in such a way that like step function work in this perceptron. Like that, a simple neuron that has the input which takes the feature through weights and biases, and then it will give kind of output with the help of the step function. So this is simple thing invented by the Frank, as I said, in 1958. So this is very useful for binary level of calculation. But what we need multi-class. For example, the perceptron works for AND problem and OR problem, but it will not work for XOR problem, 1 or 0, 0 or 1, 0 0 and 1 1. Like that, a different XOR problem, it's not suitable. So that like, and also it's need like lot of computation to run on, and also it's not suitable for lot of bigger data training. So like that, bigger challenges are faced by perceptron. But as we say that it's a very good start. Like without like having anything around, there's a strong base was built by the Frank with the help of a perceptron invention. So from here only the roadmaps exactly started. Before that there are some research papers available, but the solid basement start which starts from the perceptron. From here the roadmap starts and goes till what we are using today. So this is what about the perceptron. Now we can go to next step in the evaluation of deep learning. So now we'll be seeing about second stage in roadmap of deep learning. As we know that perceptron, it has some kind of challenges. It cannot work for logical level of problem, XOR problem. To solve this problem that perceptron faced, the inventors came with the invention of multi-layer perceptron. It is a huge game changer at that time. It can able to solve the linear problems and non-linear problems, and then it can be like a step forward to what perceptron does. For example, as we said, perceptron has three major parts: input and middle, weights and biases, feature extraction, and then output for classification. In multi-layer perceptron, as I said before, input output always same, plus or minus, and then middle part only lot of challenges and lot of evaluation happened. In middle layer, in multi-layer perceptron, lot of layers involved. Like for example, they call it the hidden layers. Lot of layers with weights and biases they have added in between. Bunch of 10, 20, 30, 40, bunch of hidden layers they have added in between. That layers help us to handle the non-linear problems, multi-class problems in an efficient way compared to the perceptron. So this was a very game changer. Now we can able to analyze multi-class problem, multi-class classification, and then we can able to work on non-linear data. So everything was possible, and this was a very game changer as multi-layer perceptron came in. So as I said, there's an input and there are a lot of hidden layers, and then output as a like a sigmoid function here. For example, here they used kind of a back propagation and a kind of like cross entropy loss functions and the optimizer function. As I said in my introduction video, while training, okay, if this is not trained, again it have to adjust some parameters, some optimizers are used to analyze the what loss. If loss is very high, then model is very bad. If loss is very low, and model is very good, in such a way that they use some kind of cross entropy kind of technique to calculate the losses of output which came from the model, and then lot of optimizer algorithm like ADAM, SGD, like that, and back propagation called, they will retrain it until they get the good result. So this is a complete invention happened after the perceptron, that is called multi-layer perceptron. But what is the challenges here? Like there's one important problem we have to notice, that the vanishing gradient problem. It's a very important to note. This problem I will be keep on repeating in multiple kind of stages in the roadmap. The vanishing gradient problem is that when model trains in deeper, as I said, in multi-layer perceptron, there are a bunch of hidden layers are introduced in between input and output. When models learn in deeper way, going layer one by one in deep, sometimes it loses like its stage, it completely lose like a learning property. Sometimes it will be like complete zero and completely stop learning. So after that, when it goes deep on layer, it will not update or learn anything. So when it comes to output, like it will be keep on one stage. For example, which is a poor and keep on back propagation, model will be always poor. It will not make any progress towards the good. So this is the one important problem it faced in the multi-layer perceptron. That's a vanishing gradient problem. And also, like we need lot of computing power for training. Since it is a completely like hidden layer based, we need lot of computation power to train it. This is the second major like problem which is faced in the multi-layer perceptron. And also I want to tell that one of the key invention happened in MLP is ReLU activation, ReLU. So this is activation which helped MLP to train the data set in a very faster manner. For example, ReLU activation means the input, that is the data, images, pixel feature that is extracted from the input images, and then in hidden layers there is like ReLU activation function is involved. What it does is that whenever negative value comes, the ReLU activation function will converts the negative value into the zero. Whenever the positive value comes, it will keep the positive values as such. So making that, it will like make the training process faster, and then it is one of the key invention in the MLP. And also we got to know that the vanishing gradient problem, and then lot of computation requirements. This is some of the challenges in the multi-layer perceptron. So this is the multi-layer perceptron overview. Now the next invention is like around 1980s, from 1958 where perceptron started, and then till 1980s there is no much progress because people are keep on working on increasing hidden layers, but the input features they are only dependent on only pixel. But in 1980s there is a big invention breakthrough happened, that is a stage called convolution neural network. So the term convolution, it means extracting the better kind of features from the images. For example, previous perceptron, multi-layer perceptron only takes the pixel features, only like RGB values or any kind of grayscale values, only that takes as a features, but there is no much difference among that. But when it comes to convolution neural network, it extracted different kind of features, kind of edges, shapes, textures, kind of different kind of features it taken from the image. That is the game changer in the CNN. So the process called convolution, there is a filter. For example, if you consider there is an image, there is a small filter size of 3x3 matrix or 5x5 matrix. It will go around the images and then it will extract the important features, for example edges, texture, as I said before, so that the input is not only pixels, no, it's the important features which is coming out from the images, so that these pictures will go around the different layers of the CNN architecture, and then like middle part, it got more innovation than previous only hidden layers, and then lot of innovation happened at the middle layer now in the CNN, since the input feature is completely different from previous inventions, so that it enables us to move forward and train for bigger problems, bigger classification things, going in deep level of learning. Everything was opened up with help of CNN invention. First, we need to know what are the different layers in CNN. So as we know that input, output and middle part. In middle part, CNN introduced multiple layers. For example, initially convolution layer, as I told you that convolution filter, which is essential for taking the different kind of features from the image, and then there is a ReLU activation. As I said in previous invention of MLP, there's a ReLU activation which converts the negative value into 0, and then positive value it will keep as such. That is second level of layer. And then third layer is the pooling layer. What it does, there are two level of pooling. One is the max pooling and the average pooling. What it does is, for reduce the computational intensity or computational efficiency, it will take some 4 value matrix. For example, there's a 4 value 4, 8, 6 and 20. What is a bigger value in this 4 value? That's a 20. So only it will take the 20 as a value, it will skip the remaining value, so that like when deep level layers goes one by one, the amount of features gets reduced, so that computation requirement also will be reduced. This is one way of pooling layer actors. This is a max pooling. The averaging pooling is that when there's a 4 value, it will take the average of the 4 value and then it will send it to the next layer, so that like in both pooling techniques, the amount of features will be reduced in the next stage of layers, so that amount of computation required will be very less in the next layers. The output of the pooling layer is the 2D form, 2D structure. The flattening layer, that's the last layer, which will convert the 2D form of the data into the 1D form, which will be very easy to do the classification task. The final 1D layer of flattening layer will be sent to the final output layer. Softmax functions or any kind of functions is used to the classification part, or the final part. The CNN layers that we understood in the simple way of explanation. So as we know that in comparing to previous inventions like input and output, middle, now CNN layer introduced lot of layers as an invention. So this is going to be the game changer for the further inventions. So this is CNN. Now let's see what are the architecture evolved from CNN architecture. So now we need to understand what are the different architecture invented with the help of core CNN concept. Let's see it. Now you have got a very good idea about what is CNN and how each layer works. So after CNN is invented, there's a major invention started to happen. That is in 1989, LeanIt was invented. Around 1998, LeanIt 5 was published. The LeanIt is a very small layers, around the 7 layers excluding input layer. Like it has like input and output in middle. In middle there are 7 layers of CNN is used, and then it is very good for small level of data sets. For example, under 200 images for 2 or 3 classes, it works very well. But the main challenge is that when data set is huge, like for example 2 gigabytes, 3 gigabytes of data, then it provides very low accuracy. It performs very poor for bigger data sets. So this is the challenges faced in the LeanIt. To solve this problem, it took around 10 years. There's a competition happened, ImageNet kind of challenge happened around 2012. There are a lot of companies, they participated. That's a very big data sets, more than 5 gigabytes of data. Like the competition challenge was who can build the kind of architecture that can perform very well and perform very good accuracy for this kind of data set. There many companies are participated. They came up with the fantastic architecture called AlexNet that is invented around 2012. In AlexNet, they have used a bigger level of convolution filter size, 11 cross 11. That's a very big. In LeanIt, it's only around 5 cross 5. But in AlexNet, they have introduced 11 cross 11 filters, and then lot of layers they introduced. A total convolution layers parameters comes around 60 million. That's a model parameter. That's a very huge. But the key invention in AlexNet is dropout. Let me explain what is dropout. For example, each layer is there in convolution neural network. When features goes from one layer to other layer, whenever the negative values, whenever the features are not trained, it will be keep on traveling to next layer. The dropout, whenever the layer is not trained, lot of negative values are there. That time whatever the values are not trained, that will be eliminated completely without sending to the next layer. This is a key invention happened in the AlexNet. Because of that, we can able to give high accuracy for bigger level data sets. So this is a very good invention for AlexNet, but there are 2 key challenges. One is the high computation cost. To make this bigger filter, computation happens for a lot of layers. We need lot of bigger GPUs for training, and then the model size also, since 60 million parameter, the model size also huge. huge. It cannot run on edge device or small computers. There are bigger computers needed for the inference. These are two challenges in AlexNet. Solve these two problems. In 2 years, the other invention came in. In 2014, Andrew and their team came up with architecture called VGGNet. In VGGNet, they have solved one problem. What they did is, in AlexNet, there are 11 cross 11 bigger size of convolution filter used in the centralized layers. These people, VGGNet, they introduced only 3 cross 3 filter. It's a very low level of small size filter comparing to AlexNet. So that what happened is that the computation which is required for AlexNet for training is completely reduced. Now 3 cross 3 filter only, so only small level of computation is needed in the VGGNet. But the model size, since VG16, VG19 are deep level layers, around the model parameters are 139 million parameters. That's a very huge comparing to AlexNet. Since one problem, the computation problem is solved in the VGGNet, but the model parameters, huge model size, is not yet solved. Even though it cannot be deployed in edge computing, it also required lot of bigger GPU for inference. So one problem is solved by the VGGNet. Another problem, that is bigger model size, is not yet solved in the VGGNet. To solve this bigger model size problem, in next year there's a good invention called ResNet. In 2015, there's a bigger invention happened to solve the bigger model size issue. That is ResNet, which is invented in the 2015 by Kaiming and their team. What is the key invention happened at the ResNet? That is the skip connection, skip residual connection. What is that skip connection means? For example, each feature goes from one layer to another layer. Even though in dropout in AlexNet, that is skipped whatever the layers which is untrained. But what does ResNet did know? They used a concept called skip connection. Skip connection is nothing but whenever layer is trained and extracted feature at one layer, even though it's not trained, input will be added to the each layer. For example, if layer 10 which is completely untrained, it's not at all useful, it cannot be transferred directly to the next layer. It will be added, input will be added to along with the untrained layer, so that the next layer, even though previous layer was completely untrained, at least it will give the input features which is given at the initial stage of the layer. So that every layer, even though previous layer is untrained, at least it will get some kind of input features, so that it keeps on goes on one by one layer, so that model size will be very low. Let me explain what is skip connection. When one layer is untrained, okay, in previously what happens in AlexNet, they introduced a dropout. If some layer is completely untrained, that is completely ignored. Okay, but in ResNet, when some layer is completely untrained, then it cannot be transferred directly to the next layer. Some initial input feature added along with the untrained layer, which will be sent to the next layer, so that any layer that receives the feature from this previous layer, if the previous layer is untrained, then at least it will receive the input layer, so that the deep learning keeps on happening. So that initially, whenever layer is training in deep level, so that vanishing gradient problem will not happen. At the deeper layer, somewhat input feature will come if there is any untrained layer, so that training was keep on happening into deep level. Because this invention, the model size was completely reduced and it is eligible now for edge computing kind of deployment and inference. So here the model size issue is completely solved, but here since layers goes into deep layer, again high computation is required. As we saw in AlexNet VGGNet, there is a high computation needed for training. The same thing was happening in ResNet also, but the other problem called the model sizes, which is not solved at the VGGNet and AlexNet, which is solved at the ResNet. So this is the invention happened in the ResNet, but the key challenge is that again high computation is required. Then in 2017, there is architecture called DenseNet came into the place. So previously we know that in skip connection, we will be adding input to the each output of a layer, so that if layer is untrained, in next layer at least input feature will be sent. But what happens in dense connection layer, DenseNet, so whenever some layer receiving the input, it will receive all the previous outputs. For example, if fifth layer is receiving its input, it is receives the combination of all 1, 2, 3, 4, 5 layers, combination of all the layers output will be given as the input to the next layer. So this is the dense connection we call it as. Due to this, model size is completely reduced comparing to ResNet. In ResNet already model size is reduced. Due to this dense connection concept, the model size even reduced more comparing to the ResNet. But in DenseNet also model size only got reduced, but even though here high computation is required as like ResNet. Now we can see that in DenseNet also high computation was required, and then if we compare all the previous architectures, we can see that some solved like computation problem, some solved like model size problem, but none of the models solved the Brothy problem. So ERST like a final, in 2019 like EfficientNet was invented. So the key formula for EfficientNet is that in previous all the layers, all the architectures, every one is focused on only one part. Somebody increases the depth of the layers, somebody will work on the size of the filters, somebody will work on the size of image input. So what EfficientNet does know, it focused on the three things at the same time. It is called as compound scaling formula of EfficientNet. The compound scaling formula is nothing but it focuses on three main elements parallelly. For example, depth of layers, and then resolution of input images, and then size of conversion filters. All three are calculated and then parallelly it's updated during training with help of AutoML concepts, and then all the things are taken care during training with help of compound scaling formula. With this invention, we can able to reduce the computation at the lower level, and also size of the model will be lesser, and also accuracy will be higher. So all these three things are solved in the EfficientNet. So that EfficientNet has lot of models. From EfficientNet B0 to B07, we have lot of models. In these models, the accuracy part, and then size of model part, and then what is the computation required, everything was the better comparing to the previous method. So it's a very key invention happened at the deep learning era. So that you can see that lot of architecture difference happened. So what are the roadmap I covered in deep learning? That are all architecture are the game changers. In middle, lot of architecture also came. For example, InceptionNet came from the Google. For example, previously all architecture used only one level of conventional filter size, 5x5 or 11x1. In InceptionNet, Google what they did, they introduced for first time 1x1 filter, 3x3 filter, and 5x5 filter. Everything works in parallel, and then all the outputs will be combined together, and then they finally give us a output model. Like that, like lot of models in between as a lower size of output size, and then lower computation, but as a result EfficientNet outperformed everything, but it solved a combined problem. So this is the roadmap of the deep learning. Because of this kind of roadmaps and the updation and the invention, today we can able to solve any kind of problem in deep learning. If we take higher level of CT scan based kind of pneumonia detection, COVID detection, MRI based brain tumor detection, abdominal cancer detection, or any kind of bigger data set, multiple class, 1000 class problems, whatever classification kind of thing we need know, everything can be solved today with help of this invention happened over the era. So this is the complete overview about the deep learning. Hope you enjoyed it. Hope you understood how deep learning started, how deep learning is shaping the future now. Now I will hand over it to the Mr. Pandian. He is a senior AI developer. He is going to go through practical projects in deep learning. So you will be learning step by step in a practical way. We have took lot of real world problems and use cases and structured lot of real world projects. So he is going to teach you in step by step manner, so that you can able to learn deep learning from scratch, and then you can become an AI expert.